Hello everyone, I am Shankar, a faculty in Women Institute. In this video, we are going to discuss control system solutions from TSPSC paper 2023. This exam was held in the January month of 2023. Now let us go to the video. Now from the question paper, I collected all the control system questions and we are going to discuss solutions of these problems. Now the first question, consider a linear system represented in state space form as shown below. State space equation is given. Now the question is, we need to identify out of these four statements which one is the correct. And just if you see these options carefully, this question is about whether the given system is controllable, observable and stable or unstable. Now let us see the solution. Now here first observation is whether we can apply the Gilbert's test or not. Okay. So in this case, in order to apply the Gilbert's test, the given system must be in parallel form, but it is not in the parallel form. How to identify whether a system is given in parallel form or not? You have to see the diagonal elements first and non-diagonal elements must be 0. But here non-diagonal elements are non-zeros, then the given system is not in the parallel form, so you cannot apply Gilbert's test. Therefore, observability and controllability can be calculated by using Kalman's test. So what is that? In order to apply this test, first you have to look into or you have to define controllability matrix. What is controllability matrix? You can see like this. The first column is B matrix and the second one is AB. Okay. So here B matrix, you can directly take this 1 and 0, 1, 0 and you can find AB. This is A matrix and this is B. AB, 0 into 1, 0 plus 1 into 0, that is 0. Next one, minus 3 plus 0. Therefore, this is minus 3. So, this is a controllability matrix. Now, if controllability matrix is full rank matrix, in other words, if its rank is 2, then you can say that it is controllable. The given system is controllable. In order to identify whether the given matrix is a full rank matrix or not, you have to calculate first determinant. Okay. So what is the determinant here? Minus 3 plus 0, that is minus 3. This determinant is non-zero. That means the controllability matrix will have inverse. Any square matrix, if it possesses inverse, then we can say that that matrix is a full rank matrix. Therefore, as this determinant is non-zero, you can say that given system is controllable. The given system is controllable. So, one part is over. Now, let us look into observability matrix. Observability matrix. So, how to define this? Let us use a symbol like this. This is C and CA. Okay. Therefore, this matrix I can write first row is 1 and 0 and C multiplied with A. Let me write down quickly here. This is 0 and 1. So basically the second row is obtained by multiplying C matrix with the A matrix. So you will get 0 and 1. Okay. Now from this you have to calculate determinant of this observability matrix, that is 1, again this is also non-zero. What do you mean by that? It is, again the given system is observable. The given system is observable. Okay, now we got two conclusions. First conclusion is the given system is controllable, and the second observation or the second conclusion is the given system is observable. Okay, now so we need to have one more conclusion, that is whether the given system is stable or not. So how can you find the given system is stable? You need to identify whether the system poles are in the left hand side or right hand side. Accordingly, if the poles are in the left side, you can say that system is stable. If the poles are in the right side, then the system is unstable. Now from the given state space model, how can you find the system poles? System poles are nothing but roots of the characteristic equation. Now let us calculate quickly here. System poles system poles is equal to roots of characteristic equation. So what is the characteristic equation here? Characteristic equation is determinant of Si minus A matrix. If you equate to 0, then that is called characteristic equation. So what is Si minus A? First let us calculate. Si minus A. S 0 0 S minus matrix A is given as 0 1 minus 3 minus 6. So from this S 0 minus 1 minus 1, 0 minus minus 3 plus 3, S minus of minus plus 6. So S plus 6. Okay. Therefore, characteristic equation is determinant of Si minus A is equal to 0. So if you evaluate this, we will get S multiplied with S plus 6 plus 3 is equal to 0. Okay. So it will give you S square plus 6S plus 3 is equal to 0. So by solving this quadratic equation, I got the roots are S is equal to minus 0.55 is one root, and another root, let me call it first root is S1, second root is S2, minus 5.45. Okay. So if you see these two roots are negative signs. Therefore, in the S plane, both the roots of characteristic equation are in the left hand side. Then we can call the given system is a stable system. The given system is stable. Of course, this is a closed loop system, closed loop transfer function. This is a stable. So what is the answer from these four options? The given system is a stable, and the given system is stable, controllable and observable. I hope there is a small printing mistake here. The system is controllable, observable and stable. Okay, so option D you can say. So this is a stable, right? So for this question, option D is the correct answer. Now let us move to the next question. In this question, Laplace transform of a function is given, that is f of s is given. F of s is equal to s divided by s square minus 4. So it's a simple function. Then we need to find out what is the f of t, that means inverse Laplace transform. Okay, therefore f of t is equal to inverse Laplace transform of f of s. Okay, so this we can say simply it is inverse Laplace transform of s divided by s square minus 2 square. So this is hyperbolic function of cos h of 2t. Okay. So as this question comes, let us write down quickly some basic formulas here. So if you are aware of these formulas, you can solve these type of questions. Now let us see some standard functions. Say for example, I would like to write Laplace transform of sine of at. Then this is a by s square plus a square. Say for example, if this particular value is given to you and if the question is inverse Laplace transform, straight away you can write out sine of at. Similarly, Laplace transform of cos of at. This you can write it as s by s square plus a square. Okay, so like this simple direct formula based questions also we can expect. That is what given in the recent exam. Okay, and similarly Laplace transform of sine h of at. This is a by s square minus a square. Laplace transform of cos h of at. This can be written as s by s square minus a square. Okay, so related formulas probably you can practice. It may come in any other exams. Now let us look into the next question. For the open loop transfer function of a system is given as g of s h of s is equal to pi multiplied with e power minus 0.25 s divided by s. Then we need to find out gain crossover frequency. Okay, so if you look into what is the basic definition of gain crossover frequency, let me write down the definition here. At omega is equal to omega gc, where omega gc is the gain crossover frequency. How to define the gain crossover frequency? The magnitude of given transfer function is equal to 1. So we can define gain crossover frequency as the frequency where magnitude of the given transfer function is equal to 1. That frequency is known as gain crossover frequency. So what I can do here, from the given transfer function, first let us define g of j omega into h of j omega. So this is pi multiplied with, where pi is a number here, e power minus 0.25 into j omega divided by j omega. This is the given transfer function. Now let us define the magnitude of this transfer function. Magnitude of the given transfer function at gain crossover frequency. How to define that? Replace omega with omega jc. pi into magnitude of e power minus 0.25 into j omega gc into 1 by j omega gc. This is also magnitude. This is equal to 1. Now exponential, this one, the transportation delay, the magnitude is always 1. Therefore, what will be this magnitude? Pi by omega gc. This is equal to 1, and hence omega gc is equal to pi radian per second. Pi radian per second. So this is the answer. So from these questions, what is a important point that you need to understand? We should be very clear in the definitions. Definitions are very important for any competitive exam. Of course, from the definitions, sometimes direct questions based on the definitions, some questions based on the memory testing, some questions will have certain logic. Okay, if you are able to catch that logic, it is very easy to solve it, but the practice is more important. Now let us move to the next question. Now in this question, if the Nyquist plot of the open loop transfer function g of s, h of s of a system passes through the critical point minus 1 plus j0, then the phase margin of the system is likely to be. Suppose if you look into the standard basic definition of, again this is also on definition part only. If you take the S plane, the critical point is minus 1, which is on the real axis. Okay. Now if, see, this is let us say Nyquist plot of the open loop transfer function. When we are increasing gain in a such a way that if the gain is simply passes through critical point minus 1, okay, that means this particular plot is for stable system, this is for unstable system, and this one marginally stable. Of course, you can also have question in this way. This is a marginally stable system. So what do you mean by marginally stable system? If you increase gain k further for this particular transfer function, the system will lose stability. Therefore, under this particular point, okay, if the Nyquist plot passes through the minus 1 point, under this particular point, you can have two conclusions. One is gain margin is equal to 1, that means you cannot increase gain further. You can express gain margin 1 absolute value, or in a decibel you can also express in 0 decibel. Coming to phase margin, you don't have further flexibility to increase the phase angle of the transfer function, so that system will lose the stability. Therefore, phase margin is 0 degree. This is a very standard question. We can have few more concepts from this. What is that? If the Nyquist plot of open loop transfer function simply passes through the critical point minus 1, system is known to be marginally stable. You can expect that question also. And gain margin is 1 in absolute value or 0 dB. Phase margin will be 0 degree. Now in this case, the question is asked about phase margin. Therefore, option C will be the correct answer. Now let us look into the next question. The Laplace transform of the differential equation, some equation is given. That equation is this one, y double dash, that means d square y by dt square, plus a into dy by dt, plus b into y is equal to f of t. Assume that now some initial conditions are given. Y of 0 is equal to 5, y dash of 0 is equal to 10, and y of s and f of s are the Laplace transform of y of t and f of t respectively. Now you need to find out which equation will be the corresponding Laplace transform. Therefore, before writing this equation, what I can say that, say for example, Laplace transform of dy by dt is equal to s into y of s minus y of 0. Okay. Next, Laplace transform of d square y by dt square. This is equal to s square into y of s minus s into y of 0 minus y dash of 0, where y dash is the first derivative. So these are the basic formulas from Laplace transform of the differentiations. Okay, you can also call it as a differentiation theorem from the Laplace transform basics. Now by using these two formulas, you can just write down, only it is a rearrangement. Okay, now let me quickly write down this one. Say here y double dash plus a into y dash plus b into y is equal to f of t. Okay. Now apply Laplace transform on both sides. Apply Laplace transform on both sides. So what you will get, s square into, let me write down this formula, s square into y of s minus s into, what is y of 0? Y of 0 is given as 5. Okay. Therefore, I can say here this is a 5s minus y dash of 0, this is given as the 10. Okay. So let us put it in one bracket here, plus a into, now Laplace transform of the first derivative, s multiplied with y of s minus y of 0, that is 5, and close the bracket. Next, plus b into y of s is equal to, right hand side is f of s. Therefore, you can arrange this equation in the form of s square into y. The options, it is simply written as just y only. The bracket s is removed just for simplicity, minus 5s minus 10, of course the same answer only it is given. So it is just y of bracket s is removed, let me write down that, 5s minus 10 plus a into s into y minus 5 plus b into y is equal to f of s given. Okay. So even it is not asked to solve that equation, it is just only write down the Laplace transform. Again, the examiner tried to test whether you remember this formula or not. This question is also based on simple memory. Now let us move to the next question. Now in this question, what is given? It is asked what is the property of the integral controller. Which of the following can be the result of introducing an integral action in the forward path of unity feedback system? Okay. So the basic property of integral action, the basic property of integral action is to eliminate steady state error. Okay. Of course, it is not asked here, but one of the problem with the integral action is it will increase order of the system by 1. Say for example, if the open loop system is a first order system, or if the given system is a first order system, by employing the integral action, of course it can eliminate the steady state error, but the system becomes second order. For the second order system, if we introduce integral action, it will become third order system. Therefore, it will increase order of the system. The chances of losing stability is high. When we are applying an integral action, we should be very careful whether the system is stable or not. Once the system stability is maintained, the basic property of this control action will be to eliminate steady state error. Hence, option B will be the correct answer. Now, let us move to the next question. In this question, the characteristic polynomial of a linear system is given as s power 4 plus 3s cube plus 5s square plus 6s plus k plus 10 is equal to 0. What should be the condition on k so that the system is stable? So whenever this type of question is given, what method you have to apply? You have to select or you have to choose Routh analysis. So let us define Routh's table here. Let us define Routh's table. You can start with the highest power of the characteristic equation, that is s power 4. Now, what are the elements I can write down here? 1, 5 and k plus 10. Therefore, the first row elements are 1, 5, k plus 10. K plus 10 together you have to take one element. Okay. Next, second row, s power 3 elements, 3 and 6. So what you can do here, you can reduce these numbers. The common factor is 3, therefore this will be 1 and this is 2 here. So these are the elements that you can define from the given characteristic polynomial. Now let us continue the remaining rows. S power 2 elements, 5 minus 2, that is 3, 3 by 1, I can say 3 here. Then you can bring this element k plus 10 here. Okay. Next, s power 1 element, that is 6 minus k minus 10. 6 minus 10, that is minus 4 and minus k divided by 3. And the last element, s power 0 element, k plus 10. So for the system to be stable, what is the condition here? There should not be any changes in the first column, sign changes in the first column. Therefore, let me write down here, condition for stability. Condition for stability. K plus 10 should be greater than 0 or k should be greater than minus 10. That is the first condition. Minus of 4 plus k should be greater than 0, or k plus 4 should be less than 0, or k should be less than minus 4. Okay. So if you take these numbers in this way, let me take here, this is a minus 10 and this is minus 4. K should be after or greater than minus 10 and it should be less than minus 4. So k value should be in between minus 10 and minus 4, and hence you can select option A is the correct answer. Now let us move to the next problem. Now in this question, one transfer function is given. Let me read the question. Consider the following statements about a linear system that has a transfer function g of s is equal to 1 minus s divided by 1 plus s. So if you draw the pole 0 plot quickly in the s plane, here there is a 0 at 1 and a pole at minus 1. Okay. So here this is a real axis and imaginary axis. This is S plane. So before that, let us see here. There is one 0 in the right hand side of the system, right hand side of the S plane. So because of 0 at the right hand side of the S plane, what I can say that the given system is non-minimum phase system. The given system is non-minimum phase system. Therefore, statement A is not correct. Next, the system is bounded input, bounded output, stable. That is correct, because there is a pole at left hand side. Because of this, you can say that the system is stable due to the pole at the left hand side. When we give the finite value or bounded input, the system will deliver bounded output as well. Hence, statement B is correct. Next, statement C, it is an all pass system. Now if you look into the pole 0 plot location, pole and 0, they are placed as exactly mirror image locations. Therefore, what we can say here, this is all pass system. Therefore, statement C is also correct. So from these three statements, B and C are correct. Hence, we can select option C as the right answer. Now let us move to the next question. Now in this question, a unity feedback closed loop system has an output given as y of t is equal to e power minus 2t into u of t, where the input to the system is a unit impulse function. Say for example, if I draw the system block diagram quickly, input is unit impulse function and it is given that the given system is unity feedback closed loop system. Okay. So this is the block diagram I can say. Let me take, this is R of s, and this is the G of s, and it is Y of s. Okay. So R of s we can take is equal to 1, because it is mentioned that input to the system is unit impulse. Which of the following denotes the transfer function of the open loop system? Therefore, you have to calculate, or simply let me write like this: find G of s. Okay, find G of s. So what is given here? Y of s is equal to, see, y of t is given as e power minus 2t into u of t. Therefore, y of s is equal to 1 by s plus 2. Okay, 1 by s plus 2. And anyhow, R of s input is given as 1. Therefore, I can say the closed loop transfer function, let me write like this: T of s is equal to y of s divided by R of s is equal to 1 by s plus 2. Okay. So basically, from the open loop system transfer function, this is equal to G of s divided by 1 plus G of s. Now from this, if you simplify, you will get G of s is equal to 1 by s plus 1. Okay. So the open loop transfer function will be option D, that is 1 by G of 1 by s plus 1. Okay. So I have noticed from so many students, of course I am not saying that they don't know the concept, but as the number of questions are more, just by in the overlook without reading the question properly, so many students selected option C as answer. Okay, that will be the closed loop transfer function 1 by s plus 2. But the question is asking transfer function of the open loop system. You have to select G of s. Now let us move to the next question. Now in this question, what is mentioned? The transfer function given as G of s is equal to s plus alpha divided by s plus beta could represent that of lead compensator. Okay. So this is another very simple question. If you just look into the basic property of lead compensator, in the lead compensator, 0 will be closer to left hand side, 0 will be closer to imaginary axis. Okay, if I stand in this way, 0 will be my right hand side direction, right? So as per the given transfer function, 0 is at minus alpha, pole is at minus beta. Now if you observe carefully, which option will be satisfying this one? Minus 1, minus 2. Therefore we can say option B will be the correct answer. Now let us look into the next question. The dynamics of a system is defined by the relation x double dot, that means second derivative of x, plus 6x dot, that is the first derivative of x, plus 5x is equal to 10 multiplied with 1 minus e power minus t. What will be the steady state value of the system output x of t is? Okay. Now first let me write down the given differential equation: x double dot plus 6 into x dot plus 5x is equal to 10 multiplied with 1 minus e power minus t. Now apply Laplace transform on both sides. Apply Laplace transform on both sides. Okay, then what you will have, see, it is not mentioned anything about initial conditions. Let us assume initial conditions is to be 0. Therefore, s square multiplied with x of s plus 6 into s into x of s plus 5 into x of s is equal to 10 multiplied with right side 1 by s divided by 1 by s minus 1 by s plus 1 by s plus 1. Okay, so if I take x of s common here, you will have s square plus 6s plus 5 is equal to 10 multiplied with s into s plus 1. Now if I take LCM, s plus 1 minus s. Okay, therefore I can cancel this s and s together, and then what we will get, x of s is equal to 10 divided by s into s plus 1 multiplied with s square plus 6s plus 5, that is the x of s. But now what is the question here? Steady state value of x of t. Steady state value of x of t means steady state value is equal to x of t when t tends to infinity for a long period of time. How to apply or how to calculate this one? By using final value theorem. What is final value theorem? Limit t tends to infinity, x of t is equal to limit s tends to 0, s multiplied with x of s. Therefore, limit s tends to 0, s multiplied with x of s. I can substitute this x of s here. Let me write down 10 divided by s into s plus 1 into s square plus 6s plus 5, right? So here I can cancel this s and s. When I am substituting s is equal to 0, what you will get? Numerator is 10, denominator is 1 into 5. This is equal to 2. Okay, so that is the answer. Therefore, option C is the correct answer. So these are the questions that we got it from recent AEE exam, TSPSC paper. So with this I am concluding this video. So what is my suggestion to the competitive exams who are preparing for the exams? You should focus definitions first and how to apply a definition or by simple formulas. So see here, this it looks more steps but simple only. So what are the concepts are applying here? Applying a Laplace transform, right? If you apply Laplace transform and then final value theorem, then you can easily apply. So what is the point I need to say here? You should be very clear in the definitions first and read the question carefully.
Mostly in the exams, what the students will do mistakes. See, for example, here steady state value is the question. So even though students know how to do it, but in the exam tension or due to less practice, they will end up with a calculating steady state error. Sometimes if error is asking, they will stop with the steady state values. So these type of mistakes mostly people will do. So try to avoid such mistakes. You will overcome such mistakes by having more practice. Okay. So with this, I will stop this video. I wish you all the best. Thank you.